All right, in section 4.5, we're going to be graphing linear equations again, but now we're going to be graphing in standard form. So what's slope-intercept form? We've already done that. What is slope-intercept form? Good, it's y equals mx plus b. Another form is standard form. Now standard form looks like this. ax plus by equals c. Now a and b are coefficients and c is just a constant. So a, b, and c are all numbers. Now a and b cannot be 0 because if they are, it's not in standard form. And you would have, like for example, if a was 0, this would be 0 times x, which means the x term wouldn't even be there. So standard form, ax plus by equals c. ax plus by equals c. So example number 1. Graph the equation negative 2x plus 3y equals negative 6. You will notice that this is not in slope-intercept form. It's in standard form. ax plus by equals c. But we're going to graph using slope and y-intercept. All right, so let's solve this thing. Negative 2x plus 3y equals negative 6. What would I do first? Good, you'd add 2x to both sides. So if I added 2x, that would give me 3y equals 2x minus 6. What about the next step? You divide by 3. Good. So I divide everything by 3. That gives me 2/3 x minus 2. So my slope is 2/3. My y-intercept is negative 2. So I would start at negative 2 on the y-axis because my graph crosses at 2. My slope is positive 2/3, so my line's going to be going uphill. Positive 2/3 means I go up 2 and right 3, or you could go right 3 up 2. It does not matter. And that is what your line would look like. Does it go through an intercept of negative 2 on the y-axis? Absolutely. Does it go up with a slope of 2/3? Absolutely. Up 2, right 3 means 2/3. But there's another part of that. These examples, we are going to graph using standard form. We are not going to put anything. We are not going to put this in slope-intercept form. So we're going to take this same example we just did. So the equation, negative 2x plus 3y equals negative 6. And we are going to graph this. We are going to graph this using standard form. So you're probably thinking, how am I going to do that? Standard form, we're going to use something called intercepts. Now we just talked about them last section. Intercepts, the x-intercept is where the graph crosses the x-axis. The y-intercept is where it crosses the y-axis. So here's how it's going to work. Remember, in your key idea, we talked about the x-intercept. When the x-intercept, when we have it, we know that y value is 0. The y-intercept is when the x value is 0. So here's how you solve using intercepts. To find the x-intercept, we substitute 0 for y. So it looks like this. Negative 2x plus 3 times 0 equals negative 6. And we solve the equation. 3 times 0 is just zeros, so we get negative 2x equals negative 6. I divide both sides by negative 2. That gives me x equals 3. So what does that mean? That means that my x-intercept is 3. That means it crosses the x-intercept, the x-axis, at 3, right there. Now the y-intercept is when I plug in 0 for x. So I plug in 0, I'm going to color code this here. I plug in 0 for x. And then I solve that. So that gives me 3y equals negative 6. Divide both sides by 3. I get a y-intercept of negative 2. That means my y-intercept on my graph is negative 2. I then connect them And it actually should be a little better than that. And that's okay. You would use a ruler and graph a line that goes through -2 as the y-intercept and +3 as the x-intercept. So let's try another example. We are going to graph the equation x plus 3y equals -3 using intercepts. So how would I find the x-intercept? How would I find the x-intercept? Good. You would plug in 0 for y. So let's do that. X plus 3 times 0 equals -3. So that will give you x equals -3. My x-intercept is -3. So I put a dot at -3 on the x-axis. To find my y-intercept, what do I do? Good. I plug in 0 for x. So I get 3y equals -3. Divide both sides by 3, I get -1. My y-intercept is -1. I connect my lines, connect the dots, and I make a line through those points to get my equation, x plus 3y equals -3. The x-intercept is -3, the y-intercept is -1. Of course, we have to have a real-life application. So let's say we have a bunch of fruit. We have bananas and apples, and we have a cost per pound. So we have $6 to spend on apples and bananas. We have to graph the equation 1.5x plus 0.6y equals 6. X is the number of pounds of apples, y is the number of pounds of bananas. Interpret the intercepts. Yeah, I love interpreting. Woohoo! I love doing that. Now, in our problem, I will tell you that I will not ever give you this equation. You will have to find it yourself. If bananas are 60 cents per pound, and X is the number of pounds of apples, and Y is the number of pounds of bananas, you should know how to put 60 cents Y. $1.50 per pound for apples, so you would put a $1.50 X. Plus 60 cents Y equals $6 total dollars. So let's graph this. So if we found the X and Y intercept, I'm going to show you a shortcut. You obviously know when you plug in something for 0, 0 times anything is 0. So if I plug in 0 for Y, that means this entire term disappears. So all I am left with is a $1.50 X equals 6. If I plug in 0 for X, the X term completely disappears, and so my y-intercept equation would be 60 cents y equals 6. If I solve both of those, I get x, which is what? What's 6 divided by a half? It's 4. And 6 divided by 6/10 equals 10. So if I graph that, I have a graph that's going to appear. Woohoo, there it is. I would graph the x-intercept of 4 and the y-intercept of 10. So here's my question. Why don't I have arrows on both sides? Why wouldn't I have arrows on both sides? Because x, which something I don't like here is that they don't label it, x is the number of pounds of apples. Y, and I ran out of room here, number of pounds of bananas. You can't have a negative at all. A negative number of pounds of apples or bananas, so my arrows do not extend in either direction. So here's our line. So interpret the intercepts. What does it mean when I have 10 on the y-intercept and 4 on the x-intercept? If we're talking about number of pounds of apples and bananas, you would actually assign x, which is the number of apples. So if you look at 0, 10, you would assign 0 to 0 pounds of apples and 10 to 10 pounds of bananas. Same thing here. The ordered pair 4, 0, there'd be 4 pounds of apples with 0 pounds of bananas. So you would write it like this. The x-intercept shows that you can buy 4 pounds of apples when you do not buy any bananas, or 0 pounds of bananas. The y-intercept shows that you can buy 10 pounds of bananas when you do not buy any apples, to get a total of $6.